All right, thank you. So today I'm gonna take a step back and talk a little bit about DevOps and what that means to me with the customers I work with, and then how that can be extended into the world of deploying and managing infrastructure, which is something that isn't necessarily new and unique, but because DevOps has the word dev in the name, immediately companies or individuals think it only relates to developers, and that is far from the truth, particularly when it comes to what can be done in the cloud. So as Ron had mentioned, my name is Ryan Berry. I'm a principal cloud solution architect working with customers like yourselves to be able to be successful in the cloud. And I've got a couple shameless plugs on my Twitter handle, and then a YouTube channel that has a number of programs on how real-world customers have solved some of the problems that I've worked with. All right, so what I'm going to walk through, I'm just let this build out, is kind of, I'm making no assumptions that you have some background definition about what DevOps means. I've got a couple brief slides of why it's important, and then talk about how that extends into doing things like configuration management. And there's a lot of different ways to be able to do infrastructure as code in the cloud. You may have heard of Terraform or kind of the multi-cloud solution, and then in Azure specifically, we have something called Azure Resource Manager template, which is what I'm going to be talking about and showcasing today. And then we'll see a couple examples. So I've got some demos that I'll kind of walk through how this all works to be able to see. I'm of the opinion that seeing is believing. All right, so what is DevOps? So it really is the culmination of people, processes, and technology to be able to help achieve some agility and the ability to continuously release updates to a product or property that you may be deploying. Could be a simple line of business app. It could be something very large like a Netflix type of a solution. And if you think about it, some of those companies that have very prominent online properties, such as the Netflixes of the world, they release, in some cases, thousands of times a day, which kind of goes against the typical grain in the waterfall approach to building and deploying software, where you have a bunch of developers kind of sit in their cubes for multiple months or maybe even a year, and then have a culmination of work kind of glued together and then deployed and rinse and repeat. And the idea behind this is to really be quick and agile to be able to deploy changes to applications, introducing new bits of functionality, additional features for customers, fixing bugs. And that also means or extends to the infrastructure that hosts that, because without infrastructure, even if you're using some of the serverless capabilities that exist in Azure, under the covers there is and are VMs or virtual machines and infrastructure that's actually hosting that application. So along with that comes the idea and premise of how do you deploy and maintain configurations across different environments, your QA environment, developer environments, and production environments. So it's really a culmination of all of this, where you have individuals coming together with the shared goal of being able to rapidly mobilize and deploy applications. So why does your organization need DevOps? I'm assuming that many of you are probably already doing this, but I do have some interesting statistics that are from a number of industry pundits that we've worked with and get research from. And as I mentioned, using some earlier examples of the Netflixes of the world doing thousands of deployments a day, these are some of the benefits you can realize, that increasing the ability to stand up a dev environment by 100x plus. So think about all the times where you might have a line of business application that you want to deploy, and you've got to talk to some infrastructure person that has to rack and stack a server, or maybe even backing up farther up the chain, you have to get approvals to actually purchase that hardware, install the operating system, configure the operating system. And that process certainly takes time. And thinking about that critical element of infrastructure when you're actually deploying an application, we'll talk about the various different ways that we can automate a lot of that. Certainly, many fewer code deployment issues, And I've seen this again and again with customers I've worked with in days gone by, where you have a pool of 20 web servers, and when a user or customer hits one of those 20 web servers, they get a undesirable experience, and because of some misconfiguration, because somebody connected to that server manually, made some configuration change that nobody was aware of, and when a user hits that particular node, bad things happen. So the idea is to introduce some level of consistency in automation, to just have robots rule the world, so to speak, in deploying applications, as well as the configuration, as well as things like operating systems and requirements within an operating system. Also have fewer deployment failures. Think about all the dependencies that might be needed to deploy an application. You have a .NET Core application, you're going to need a .NET Core runtime installed on all the servers hosting that application. So if you think about that from very early on in the development process or development life cycle, that and include the modeling and development of automation to be able to deploy those dependencies, you can reduce the number of failures. And then also, we'll talk a bit about security that I think is really cool when you combine something like an Azure DevOps with a workflow that actually is deploying your application into the cloud. I'll give you a specific example of this, where I have customers where no human being actually has access to the production environment. So they have identities that are established in DevOps. So upon approval, some business decision maker approval saying, yep, we're ready to ship this particular build out to production. The engine, the Azure DevOps engine, as it were, actually does that deployment for them. So no human is actually logging in, making any changes. They can see it, they can't actually change it. So obviously with that, you have many benefits, including enhanced security, because you can ensure that nobody's tweaking with things and overriding firewall rules and that sort of thing that might create a condition or situation where you have data exfiltration. So all of these benefits can be realized by implementing and using some of the principles of DevOps. So one of the tenets of this, aside just from deploying code to an endpoint, whether that endpoint is a service in Azure or that endpoint is a virtual machine in Azure, is to establish some hygiene around configuration management. And by that, what do I mean? So, think about configuration files, connection strings, other endpoints to dependent services that you might actually be needing to invoke, and then marry that with the fact that you want it to be what we call idempotent, and by that I mean, and actually I'm going on to the next slide, idempotent and consistent. And this is something that can't be achieved in some of the ways that we've done things in the past. So what idempotency means is that when you run an automation job against your environment or your infrastructure you're deploying your application to, and then you turn around and run it again, that it's not going to delete services, it's not going to fail. So you want the application or the deployment operation to not care or matter if there's already an environment in existence, and also you want it to do the same thing every time it's ran. So you can do that using some of the traditional ways, such as creating a bash script or shell script to be able to deploy your application, or PowerShell scripts. And I tell you, I have seen some monster automation scripts to be able to deploy applications. I've got one customer, I think it was about 1,500 lines of bash script. But the challenge there is that if let's just say that you have an operation that wants to create a VM in Azure. So a script that would actually be necessary to do that, you'd have to first obtain some level of credentials to get to your cloud environment from someplace, and then you'd have to connect to that environment to see, does that VM exist already? Is there already a VM there with that same name? So you'd have to have all this if-then-else type or try-catch exception handling that you'd have to put into every script that you author. So the idea behind this is to take a step back from that and use some of the tools that are available to make that much easier. That actually already takes into account and has the ability to peer under the covers and see, does this service already exist? Yeah, it does exist, we just want to change, maybe add another network card to the VM as an example. So, the configuration management automation has the ability to be able to do that introspection, regardless of where you're deploying, whether on premises, Azure or other clouds, and make those decisions for you. So, some examples of that in the configuration management world are desire state configuration. That's the Microsoft way of being able to instill some level of consistency across pools of virtual machines, and we'll see that in action today. Azure Resource Manager templates, which we'll also see in action today, as well as some of our partners like Chef and Puppet, have the ability to create recipes to be able to deploy and automate, the installation of, Apache on all of your Linux machines, and configure Apache in a consistent manner across all your Linux machines, as an example. So these are all tools that apply to some of the things that I just talked about, and all of these remove the element of the scripting nightmare scenario where I talked about, where you'd have to have lots of exception handling to be able to help you in deploying that application. So let's take a step in to see how Azure can solve some of that. So we have in Azure a number of different solutions that you can use, such as Azure DevOps as well as GitHub. So both are platforms that can be used or leveraged to serve as a code repository and to have what we call pipelines. And think of a pipeline as really just a workflow to be able to facilitate having an engine do something on your behalf. And when I talked about the customer example earlier, where they were not, where no human being had actual physical access or logical access to the environment that they were deploying into, it was only the Azure pipeline that actually is using an identity that actually did have access to the production environment. So it's a way to have a level of control over that. And one thing that I found in talking with customers about implementing something like this is you invariably have these silos. You have a security team, maybe a networking team that focuses on all the network infrastructure, routers, switches, firewall rules. Maybe a server team that configures the servers and deploys patches to operating systems, configures them in a secure manner. Then you have the developers who just want their stuff to freaking work. And usually you have some arguments can instill across all those different teams. And if you take a step back and actually think about having the developers work with the infrastructure team to define what infrastructure is needed to run their application. And if you have a secure manner to be able to facilitate deploying that into a production environment, you can usually get over all of the hurdles and obstacles that come into play, from the security and infosec teams that tend to be pretty cautious and paranoid about things being deployed into production. So we also have some facilities such as Azure Key Vault, which is a element or a capability in Azure that allows you to store secrets. So using my customer example that I recently worked with, they have a key vault that actually has all of the identity or the usernames and passwords to SQL databases and so forth. So again, no human being has access to that key vault. They do have a break glass account that they can get to those environments if they need to, but under normal operating conditions, no human has access to that production environment or to the key vault that contains all the secrets. Only the sentient being that is Azure DevOps pipelines and the ARM templates do have access to those secrets to be able to pull them out and plunk them into the application. And the bottom part of the slide kind of talks about the different open source capabilities we have, with GitHub, Jenkins, Terraform, Ansible, and ElkSec. So these are all for monitoring on the ElkSec. It kind of glossed over the application insights that we have available in Azure. So we're open and work and interoperate with a lot of other solutions that, again, you can use Azure DevOps pipelines as a vehicle to be able to kickstart some of the things that are shown in the bottom of the slide. All right, so I'm kind of going rapidly because I want to make sure I get to some of the demos I have. So one of the key ingredients of the demos that I'm working with that I'm going to show you is something called Azure Resource Manager template. And if you've not worked with it, it's a way to declaratively describe the infrastructure that your application needs, much like I mentioned Terraform earlier. This is the Azure-specific variation or flavor of that. And basically, what it is comprised of are groups of variables that you would have the user provide to you when they actually deploy that template to an environment. And those, parameters. And then those parameters can be used to create variables, the local variables that are, in this example, it's actually doing a string concatenation with website and creating some unique string. And then, the underlying resources that are needed to be able to support the application you want to deploy. And the benefit of this is that it is completely idempotent. So if you run this against a resource group or container in Azure that contains all of these resources, and then run it again, if nothing is different in your template, it will run extremely quickly, maybe in seconds, because what happens is that template submitted to Azure, Azure evaluates it and looks and compares to get what you're asking to deploy against what's already deployed. And when it sees there's no difference, it won't make any changes. If, however, you did something like maybe change the capacity of the server farm that you're deploying, the number of instances, it would only make that change as opposed to tearing everything down and redeploying. So it provides all of that if then else or try catch type error handling I talked about that you would normally have to deploy yourselves if you're using a traditional script to do some of this configuration management. So, and I already talked about this a bit on the last slide, that the ARM templates are idempotent, and they simplify the ability to roll solutions out and also to roll back. So, like if you make a change to a web application and realize it's not a configuration change you should have made, you can make a tweak to your template and redeploy, and that change will be rolled back. Or if you are using version control, which ARM templates are just files, they're JSON files, you can roll back to the previous version and deploy that. So I'm going to jump in real quick just to show you an example of an ARM template here. This is an ARM template that's actually deploying a pool of virtual machines. So I have a number of parameters, such as what operating system version I want to use, what the size is of the VM that I want to deploy, and we'll talk a bit about some of the stuff below as I kind of walk through some of my examples. Then I have a number of variables, and variables are just local values that I'm creating off of some of the parameters that are actually pulled in. Making sure the name of my VM scale set environment is lowercase to make sure it pacifies the requirements of Azure, as an example. And then finally, the ARM template has parameters such as the resources that I want to deploy, rather, such as the virtual network, storage accounts, and then finally the virtual machine scale set. So this looks cryptic and confusing, but I'll show you in the portal that there are some ways to be able to build something graphically using the Azure Portal and be able to extract out these templates that you can then use as a basis for your automation. All right, so let me see here. So ARM templates, think of them as the outside of the box element of, or envelope of the resources you want to deploy. So they describe the what, what the subnet ranges are in a virtual network that might be needed to house virtual machines that ultimately have an application running on that. So once that infrastructure is deployed, an ARM template can be used to poke that infrastructure after it's up and running, using things like desired state configuration, Chef, Puppet, or running a PowerShell or Bash script on that machine when it comes up. And I'm going to show an example of all of this here in a moment. All right, so let's take a step back about all the stuff I've just talked about and kind of see it in action. So I'm going to start with a sample web application, so .NET Core application, sitting in a Azure DevOps repo. And I have a build template that actually will take, upon check-in of a change to that source code, it will build all the new binaries for my application. And then I can trigger a deployment pipeline to actually deploy that application with the required configuration changes, so such as connection strings, databases, and that sort of thing, to an app service. This is a really simple example, and then I'm going to kind of step away from that and make them progressively more complex. So what I have is, this is actually, the source code doesn't really matter as much, but this is just a simple .NET Core application. This is, you see it's all checked into source control. This is actually the application that I'm deploying. Nothing too particularly fancy or of interest necessarily with this. And if I jump over to the Azure Portal, let me go here. So this is actually the source repository where all of this, oops, in the wrong one. This is the source repository where all of that stuff sits. So this is that employee portal I just showed you. This is the source code for it. So in Azure DevOps, we have this concept of pipelines, and I've got a couple of pipelines here. This particular one right here, the Library CSE test, continuous integration. So when I do a check-in, this will actually build my code. So this is a pretty simple pipeline that actually, and I'm using. We have a couple different ways to build pipelines in Azure DevOps. One is to use a XAML-based or JSON file. I've opted for the classic one to be able to show you kind of more graphically what's going on here. So this is just doing a simple build of my .NET Core application, and then I published the output to make it available for the next step of the operation, which is the release phase. I'm going to show you some interesting things that I can do with those artifacts to deploy it first to an Azure web application. And then I'll show how I can deploy it to a VM, and then I'll show some more advanced variations of that. So this is what we call a release pipeline, and this is that workflow that I talked about. And you can see as an input, it's actually taking the source code for my web application, and I have a simple set of stages that it actually uses to deploy this application into production. And the first thing that I'm doing is I'm obtaining some secrets from an Azure Key Vault. So this would be an example of what I described earlier, where you have Azure DevOps itself being the only vehicle that can be used to connect to an Azure subscription and get secrets out. So in this case, I can use them to transform my configuration file with connection strings, usernames and passwords and that sort of thing. So I have a couple disabled tasks, but you can see this is a pretty simple pipeline that literally has two tasks. Get my secrets out and then deploy my applications. So I have a task here that allows me to interact with an Azure subscription and to deploy in this case, I'm deploying a application called Library CSE Test, which is a web app that I have sitting in Azure, and it's taking the output of my build, the zip file for my build. And also, I can optionally go in here and say I want to do substitution of parameters in my configuration files. This is where I can take a secret called admin password, maybe from my Key Vault, and it will replace that in the JSON file in my app settings configuration file as it's deploying it into Azure. So this is a really powerful feature where you don't have anything that gets passed in the command line. You don't have any passwords that are stored in environment variables. You don't have any passwords or credentials that are leakable, in a log file or anything of that matter. That it's actually done as part of the deployment operation. Will suck out all of the secrets from Azure Key Vault and deploy them into my application. So this is a. Let me go ahead and go in the Azure Portal. I thought I already had that open. Maybe it's just in one of my tabs that's hidden here. So this will deploy that application. So while that's loading, I apologize for this. Oh, that's my Cosmos DB account. I have it named the same. Let me just go here. All right, so this is the application that my DevOps pipeline is interacting with. And if I were to run this this pipeline, which I can actually do just by going back to my pipeline, and I'm going to go here and I'm going to say I want to create a release, and I can tell it that I want to deploy. That if you recall in that pipeline, that I can have it go through a number of steps. So the benefit of this is that I can, and I'm going to go back into this pipeline just for talking purposes. So in stages, I have this stage called dev, and one thing that's often the case is that you want to take a build 1, 2, 3, and you want to deploy into a development environment, and then you want to move that exact same build in an unmolested state, unmodified. You don't want to recompile that, because now that would introduce change into the code base that you've already verified in dev. So you can have another stage to actually deploy that into a QA environment and then carry that over into a production environment. In my case, I just have a single stage, but I just want to highlight that this is a powerful capability of Azure DevOps to kind of carry that code base through all the various different environments. So if I go back to my pipeline and say create release, I tell I want to deploy in my development environment, and I can pick. I'm actually triggering one manually. I'm taking the latest build that I have and hit create. This will actually trigger some machines that are in the cloud. I'm going to actually kick this off. So, and when it actually starts running, we'll be able to actually watch it. So this is actually going to get a machine that's in Azure DevOps, part of our Azure infrastructure, and it's going to pull down all of my source artifacts, and then it's going to run all of the steps that I had in my template. You see here is actually getting the Key Vault artifacts that I had skipped, and it's downloading my code artifacts. And right now, it's actually deploying the updated version. And you can see it is actually masking out the credentials, but it is actually shoving in the username and password, my Cosmos DB. And just like that, that version of my web app is deployed. So the idea of this is idempotent, it's consistent, it's a repeatable way to deploy your application into in this case, it's using a PaaS environment. So let's step forward into the next example, which is where I want to take that same application, and instead of deploying it to a PaaS environment, I want to deploy it into a VM with IIS installed on it. So Azure DevOps has the ability to interact with agents that are running on a virtual machine. And you can install those agents on any virtual machine you wish. There's no licensing impact for that. So I can give you an example of that. I have a customer who has a software as a service solution, and they literally have the DevOps agent on every single one of their machines. They've got well over 1,000 virtual machines now running in Azure, and they can remotely control them through Azure DevOps. So it's a very firewall-friendly way to be able to remotely instruct that machine to do things. And by that I mean, running a PowerShell script, or installing a new version of .NET Core, or poking it and telling it to pull down a new version of a web app, or configuring IIS. All of these things are possible by having an agent running locally on that machine. And that the other thing I mentioned is it's firewall friendly. The machine actually reaches out to Azure DevOps to see if it has work that needs to be done. So it talks to Azure DevOps over 443. It doesn't actually need any inbound access to the machine. So it's a very secure way to be able to interact with Azure pipelines to be able to see if there's any work that needs to be done. So let's see how that works. So if I go back to my portal and go back to my releases, I have another one called Deploy to VM. And again, it's taking the same output from that build I just showed you. And I have a couple of additional tasks in here now. So now, and I'm going to back up. So one thing that you can do here is that I can actually create a pool of machines. So like my customer example, I said where they have well over 1,000 machines that's in their environment. So you have to deploy that agent on it, and register it to a DevOps repository, which I've already done. And you can see that I have one target matching this machine. So the cool thing about this is that you see I have a tag on here saying West, saying I want to deploy this to my virtual machines that are in the West, so of which I have one. So I actually have two machines that are actually part of this. In fact, if I remove this, you can see I have one in the West Coast and I have one in North Central U.S. So I have those environments tagged that allows me to very specifically target a subset of my infrastructure to instruct it to do things. And if there is more than one, I can also control if they're done in parallel or if it does them one at a time. So one of the things I'm doing is installing a Chocolatey package manager on that virtual machine. And then also making sure .NET Core is installed on that virtual machine. And then I'm configuring IIS. So now I'm in the realm of the virtual machine, not using the app service I just showed you a moment ago. And I created a virtual directory called employee directory. I'm pointing it to a local directory on the disk. I'm telling it the app pool that's running on. It's a .NET Core application, so I don't have any managed code. And then finally, I'm taking that same zip file and I'm pushing it to that application. And the benefit of this is it's all running locally on that machine. So that machine is periodically saying, okay, DevOps, do I have any work to do? And as soon as I queue up this release, that machine will pick up that job and actually pull down the code artifacts needed to make this deploy function, and it will walk through all of these steps. So this is taking that same code and just deploying it to a virtual machine. So let me get to the last and final example.
Hey, Ryan,
yeah,
this is
sure.
Great stuff. Just to keep things moving along, if you could try and finish up in about 2 or 3 minutes.
Yep, absolutely. This is the last example. Yep. So what this example is doing is it's mimicking a more complex scenario where you have a number of infrastructure resources, virtual machines that you want to deploy. In my case, I have a service, a Windows service I want to deploy to this virtual machine. So this is actually taking into account some of the things I talked about earlier, the desired state configuration. So I have an ARM template that has definition for my infrastructure. I have the code for my Windows service. And then I have a desired state configuration script that actually that pokes my machine after it's up and running, and then tells it to actually go out and retrieve the .NET service that I've written and install it on that machine. So where this is hugely powerful, if you think about the traditional approach of treating infrastructure as pets, where somebody builds a VM, takes care of it, and installs something to it, and then you want to install an operating system update. So that typically involves some human being or maybe some level of automation that the organization might have to connect to all those virtual machines and install an operating system update. The benefit of this automation is that you can have it completely tear down your environment and rebuild it in minutes using the latest operating system versions of VMs that the images that we have available in our marketplace, and then instructing those VMs to deploy the latest version of your code. So the idea is to kind of remove the element of having to take care of the operating system and nurturing it, and have the DevOps deployment pipeline use that ARM template and a DSC template to do that for you. And for the sake of time, I'll show it to you, and I have that actually in, let's see, releases, create VM scale set. So this is a little bit more sophisticated example that is taking my ARM template that I have in source code, source control, which happened to be this ARM template I showed you a little bit ago. That's creating my virtual machine scale set. There's one thing I'm going to highlight in here that I'm actually making use of, is this PowerShell desired state configuration extension. This is a bit of stuff that gets deployed to that virtual machine. And then once it's deployed, I'm telling that desired state configuration engine to run a script. And what that script does, this is actually that script. It knows what storage account to go to be able to pull down my source code, and and it has an identity that I'll talk about here in a second that it actually uses that's only accessible within that VM. So this is all stuff that runs in that VM automatically when it comes up. So what I have to actually do is compile that desire state configuration script. I upload that desire state configuration script. You can see that that was that proc.dfc, that was actually that PowerShell script I just showed you. I take my service, my Windows service, I zip it up, I upload that to a storage account, and then finally, I have this magical thing down here. This is ARM template deployment. So this is actually using that, that ARM template that I just showed you, and I'm passing in a number of parameters on where to go to be able to retrieve that service, you know, what the name of the service is, what the storage accounts are. That's what all of this stuff is. But one thing that is in here is a what we call a SAS token. This is a temporary token that's created for me by this step that actually allows that desire state configuration script to have the authority to, or privilege to be able to hit that storage account and pull things down. So this is a powerful example that I can actually so you can employ to stand up infrastructure and then tell that infrastructure what to do once it's up and running. So it does. You know, this allows me to tear down an environment completely and rebuild it. I don't have to do anything special with that virtual machine once it's stood up, because my desire state configuration template has all of the detail of what's needed. And you can see down here, it's actually I'm using it to actually pull down my Windows service, and somewhere down here I'm running the .NET utility, the install util. This is actually part of the .NET command line tools. I'm actually installing and registering the service. It's called processing.exe on that VM. So this all happens in you know, a matter of minutes. And if I just kick this off as one final example here, it'll actually you know, start running this in Azure on resources that are available you know, in Azure, that's actually, you know, instructing it to run all of these tasks, and then you know, ultimately deploying this template to you know, to my environment in Azure that actually contains all of this infrastructure. So this is kind of the end of the example here that I'll go ahead and, for the sake of time, that was my last slide.